Okay, we are on to the next slice, and we are on to secondary hemostasis. Just make that go away a second. So, I suppose I better write while I'm doing this. I wanted to do this on the light board. However, I couldn't book a slot, and it was imperative that we just got on with it. So, I want to make sure that I'm here. So, oh goodness me, what is going on there? Let's move you out of the way. Getting better. Okay, let's try this again. So we're on to coagulation. So coagulation equals secondary hemostasis. Okay, that's the first thing that we need to say. So what does it do? It is essentially, there's two different ways of thinking about it. Number one is a cascade. Okay. Number two is what actually happens. That's a difficult thing to actually say to any students. So it's like, I'm going to teach you this thing. I'm going to teach you this cascade, and then I'm going to tell you that none of that actually works or happens, and then I'm going to actually show you what really happens. So then the question becomes, well, Lewis, why are you telling me any of that? And the answer is because you need to know it. Why do you need to know it? Because of this. So all the coagulation tests that we do come from the cascade, not what actually happens. Well, when I say all the tests, all the clinical tests that we do, what actually happens is the research tests. And I'll introduce you to them then later too. Both of them, though, both of these things, so the cascade or what actually happens, they are both interested in activating thrombin. For goodness sake. Thrombin. And then thrombin turns fibrinogen into fibrin. Now that's important because, as we've already been saying, that if we've got our endothelium like this, okay, we've got a von Willebrand factor there, we've got a platelet bound to that, and then we've got some platelets holding hands with other platelets like that. We said that the thing that is binding them is fibrinogen. And the problem with fibrinogen is that it is soluble and it can be easily broken off, and that little platelet there can float off into the vasculature. Okay, so we need, in order to be able to heal any damage in the vasculature, we need to be able to turn that fibrinogen into fibrin, because this fibrin is insoluble. So how does this all work? Well, we're going to start with the coagulation cascade. Okay, so let's tidy this up. And we'll just delete all of them. And we'll get on with talking about what actually we need to learn. That's a little bit of preamble for you. So what we've got, and we're going to start with the cascade. All right, so I suppose I'm going to write this up here. Cascade, otherwise known as the med school version of what happens. So we've got key factors, coagulation factors. Okay, coagulation factors. And these are all what are called zygomins. Okay, zygomins. Now, what does that mean? It means that they are what is called inactive precursors. So, an inactive precursor would be, let's use factor 10, because they're all in Roman numerals. Okay, all of them are in Roman numerals. So 10, 5, 2, which is prothrombin. Okay, so that's actually probably a really bad one to do. Say 8. Okay, so they're the inactive precursors, and then they become activated. And when they're activated, they gain a little A by the side of them. Okay, like that. You may see some people, and I might do it actually, might put the bars on these. Okay, like that. For some reason, we don't do that with 10, but hey ho. So that's that. That's that little bit of housekeeping. Okay. The question should then become sort of, where did these reactions happen? The vast majority, okay, so we'll write this here, majority of reactions, they happen at membrane surfaces. Okay. Why is that? Because there are binding sites there. So this is either going to happen on membranes of the endothelium or platelets. Okay, so that's the next thing. There are some coagulation factors. Okay, some factors are what's called vitamin K dependent. So Vit K dependent. Okay, these are it's the ability to write today. Thrombin, factor 7, factor 9, and 10. Okay. Thrombin, 7, 9, and 10. And what does that mean? Well, it just means that they need vitamin K so that they can actually be churned out in the liver. Okay. In the lecture notes, I've actually put the whole cycle of vitamin K, and you're more than welcome to look at it. But what do I need you to know? Well, I need you to know that these are the vitamin K dependents, and that if something is vitamin K dependent, then in order to negate them, we require warfarin. So warfarin will knock out any of these. So this ties back to the idea of this is where all the clinical tests come from. Okay. So I think the best thing that we can get on with now is actually describing this cascade. Okay, so let's move these up here. And let's get on with it. Now I'm going to teach this to you in two different ways. Okay, I'm going to teach it to you the way that it was taught to me, and then I'm going to teach it to you in a way that is actually easy to to remember. So the way that it was taught to me is we've got two different pathways. We've got the contact factor pathway, okay, and we've got the tissue factor, and these were previously called the intrinsic and the extrinsic pathways. All right, here we go. Contact factor pathway starts with coagulation factor 12 becoming activated to 12A. Okay. Then 12 will activate 11, and then 11, because this can't possibly be easy, activates 9. Nine activates 10. And I'm going to do this like this, okay, because this is kind of where the other pathway we have to start talking about. Because 10 is going to activate the first step of what's called the common pathway. And that is, it activates prothrombin to thrombin. And we've already talked about what it is that prothrombin does. Okay? We've said prothrombin, will take fibrinogen and turn it into fibrin. Okay, so then we've got, that's one pathway, and then we've got a tissue factor pathway, and the tissue factor pathway happens on vascular injury. Tissue factor pathway is when factor 7 comes into contact with tissue factor. So factor 7 goes to 7A activated plus tissue factor. That, let me do this, turns 10 into 10A. Cool. But there's something else that happens. So I'm going to change colors here to green, because this is crosstalk and feedback loops. So this used to be it, by the way. This is just what we thought at one point this entire cascade was. And then we realized that actually tissue factor will also help to catalyze this step. Okay, so I'm going to do that for a little bit of crosstalk there. Okay. Now, what else happens is that thrombin goes ahead and does a couple of things. So it'll come up to the line over here, like this, and then I'll say what thrombin does is it also activates factor 11. Now the other thing that it does is it activates factor 5 into 5A, which then activates factor 10. And it works with factor 10 to turn more prothrombin into thrombin. And then the other thing that it does is it activates factor 8. So I'll just go 8A because I'm running out of space. And that is going to also help this step here. So factor 9 activating factor 10. So what should immediately become apparent to you is that that's horrible. And it is. It's a really horrible way of learning things. So there's a simpler way of doing it. And that's what I'm going to show you now. So I want you to basically think about it. The easiest way to do it is to just first and foremost get rid of the Roman numerals. You can put them back in later, okay? And we're going to start off with factor 10. And if you want to, we can put circles around them or whatever. I don't mind. I can just do it like this. I prefer to do circles, so I'm just going to do circles. So 10. Why do we do 10? It's easy to remember 10 because 10's the best. Yeah, he or she is a 10 or they are a 10. So we'll put that in the middle. All right, here we go. Now all we got to do in order to understand coagulation is to count from 12 down to 1. Okay? So prothrombin or thrombin, this is factor 2. So that explains why I didn't want to say that earlier. This is factor 1. Okay? So we need to be able to count from 12 down to 1. So that's fairly easy, isn't it? So we can go, right, okay, we'll do coagulation factor 12. Then we'll do coagulation factor 11. We've already got 10. What comes next? 9. Cool. Look at this. 12, 11, 9, 10. Here we go. 12, 11, 9, 10. Now what did I say that we needed to do in order to understand coagulation? Count down from 10 to 1. Okay, 10 from 10 to 1. Prothrombin, fibrinogen, or thrombin and fibrin. Okay, cool. That, if we look at this, is basically the original contact factor pathway. Okay, but didn't we have another one that we needed to draw in? Yeah, okay, we did, yeah. So we just put this down here. And then this is the original tissue factor pathway. 7 activates 10, activates fibrinogen, activates prothrombin, activates fibrin. Cool. Well, what about all of those complicated feedback loops? Okay, right, we got some little ones to put in. We don't need to worry about the crosstalk between 7 and 12, unless we particularly want to. We could do this. Okay, if we wanted to, but we've already got a 7 down the bottom anyway, so, big whoop. We'll leave it in. Actually, no, we won't. We'll take it out just because we're being clever about things. Okay, so where's the rest of the precursors? Well, the rest of the precursors are found like this. We said prothrombin has a feedback loop. So the activation of thrombin, has a feedback loop. And that feedback loop activates coagulation factor 5. So what's an easy way that we could remember this? Well, we'll still do our color change, okay? And we can say that we need to remember that we've got to put coagulation factor 5 in somewhere. Well, 10 divided by 2, 10 divided by 2 is 5. So we put 5 at the top here. And we remember that 10 and 2 have a cofactor of 5. Cool. Now, what was the other one that we said that we had? Well, we needed coagulation factor 8, didn't we? Yeah. So what are we trying to do? We're trying to count backwards from 12 down to 1. From 12 down to 1. So we've got 12, 11, 10, 9. What comes next? 8. And then remember that 9 and 8 go together to make 10. We can also, if we wanted to, remember that there's yet another cofactor here, because whenever coagulation factor 8 is involved, usually von Willebrand factor isn't too far behind. But the easiest way to remember this is that if you, like bingo, that's 2 fat ladies, 88. That's 1 fat lady, number 8. But it's not. She's not a fat lady, she's a queen. And a queen needs a crown. There's your crown, von Willebrand factor. So we'll do that. That's coagulation. Nice and easy. Now, there's some other things that we can do, because this setup allows us to remember a couple of extra bits and bobs. We said some of these factors are vitamin K dependent. Look at this. This T section. Yeah. They are the vitamin K dependent factors. 10, 9, 7, and 2. Factor 10, factor 9, factor 7, and thrombin. Look at that. Thrombin, 10, 9, 7, and 2. They're there in that T section. The other way to remember is that vitamin K likes disco. Why is that? Because vitamin K was born in 1972. So you remember that the 1 is a 10. Now this is something else. There's something else that we can do. I'm not going to draw it, but I'm going to put a name. You see this section? Yeah. It's kind of making a gun shape. Okay, that's the tissue factor pathway. And on this diagram it looks like a gun, which is the easy way to remember gun equals war. And then we'll do this in another colour. Great. So the gun requires, if you have an abnormality in 7, 10, 2, and 1, it can be treated with warfarin. This is the intrinsic pathway, or the contact factor pathway. Okay, and that is treated with heparin. So if you have an abnormality in 12, 11, 9, 8, 10, 5, 2, 1, on your coagulation screen, that's usually going to be treated with heparin. If you have it in 7, 10, 2, and 1, or 5 as well, you can add that in. That's the noted gun, which means your first choice is warfarin. So that is the coagulation cascade in 24 minutes. I hope you found that useful. Next thing we're going to do is what actually happens.